So we are on the last question here. I'll read out the question. A spacecraft flying in a straight course with a velocity of 75 km per hour. So this is the spacecraft. It is flying in a straight course at a velocity of 75 km per hour, fires its rocket motors for 6 seconds. At the end of this time, its speed is 120 km per second. Let's say this is the point where it starts firing, starts rocket engine, and it fires for 6 seconds. So let's say this is total of 6 seconds, and this is where the rocket engine stops. So what does it say? Yeah, so rocket motor stops in this case. So this is where the rocket motor stops. Perfect. So this is firing only for 6 seconds. At the end of this time, its speed is 120 km per second. So here the speed is 120 km per second. Done. In the same direction, find the spacecraft average acceleration while the motors were firing. So we need to know the acceleration in this time. Well, for that I need to know I need to know the u. What is the u? U is given as 75 km per second. So this is at this time the speed was 75. At this time it is 120. I know the formula. Acceleration is equal to v minus u upon t. V is 120 minus u is 75, t is 6 seconds. So 120 minus 75, that's 45 upon 6 kilometer per second square. 45 upon 6, 6 sevens are 42, so that's 7.5 kilometer per second square. So part 1 of the question done. The average acceleration was 7.5 km per second square. Distance traveled by the spacecraft in the first 10 seconds after the rocket motors were started. So from here, the rocket motor was started and they want the distance traveled for 10 seconds, which means let's say till here, this is the 10th second. This is where the vehicle started, and this is for 10 seconds, 6 seconds, it kept on accelerating, and then it moved at a constant speed of 120 km per second, and this is the time 10 seconds. They want us to calculate the distance traveled by the spacecraft in the first 10 seconds after the rocket motors were started, the motor having been in action only for 6 seconds. So this is where the motor is starting, this is where the motor is working, this is where the motor is not working, and it is moving at a speed of 120 km per second. So let this be distance 1, let this be distance 2. So for distance 1, right, we know the formula v is equal to u plus at. That doesn't give me distance. V square is equal to u square plus 2as. Well, that can give me the distance. And even the other one, which is s is equal to ut plus half at square. So let's use s is equal to ut plus half at square. This is for my first part of the distance. So the distance traveled will be u. At this point, u was 75 multiplied by time for which the acceleration happened is 6 plus half. Acceleration we've calculated at 7.5 in the previous step, and the time for which acceleration happened was 6. So 6 into 6, 2 1 2 3, 75 into 6, that's 420 plus 30, that's 450, and 18 into 7.5, that's 135. So that's 450 plus 135, that's 585 kilometer. The units were kilometer, so this is kilometer. Now let's look at this distance. So for distance 2, is the speed increasing? No, because the motor has stopped, which means it's moving at a constant speed. What formula do I know? Well, I know speed is equal to distance upon time, which means distance traveled will be equal to speed into time. In this case, the speed at this point was 120 multiplied by time. How much time? This is 6, so how much time this is? Yes, this is 4 seconds. So 120 into 4, which is 480 kilometer. Therefore, total traveled distance traveled will be equal to S1 plus S2, in this case 585 plus 480, which is equal to 91060, 1065 kilometer. So for me, this finishes the questions that I had to do from the numericals. Now the questions that you need to do on your own are as follows. Question number 4, question number 4, question number 6, question number 8, question number 11, and question number 15. Thank you, take care, and be safe.